I'm Dan Huttenlocher, the Dean of the MIT Schwarzman College of Computing, and I'm delighted to be here today to talk with you about computing at MIT. The vision for the new College of Computing, which was started in late 2019, beginning of 2020, is to bring together studies of computing ranging from hardware to software to algorithms to artificial intelligence, because computing is becoming part of the intellectual fabric of every field. It's moving beyond just being a tool to being part of how people conceptualize things in disciplines across the institute and in almost every area of human endeavor. But one of the challenges that we all face in academia and more broadly is that the pace and the scale of this change are overwhelming conventional ways of doing things, and particularly in the academic realm, overwhelming conventional research and education pathways. So in academia, we see three critical consequences of this that the college is designed to address. One is the skyrocketing demand for computer science programs and classes. The second is that the relevant advances in computer science and artificial intelligence often are not accessible to people in other fields. And the third is that broad and rapid applicability of computing calls for a better understanding of its societal implications. So the college cuts across the 5 schools at MIT. It's both cuts across the intellectual fabric of the whole institute and invests in the forefront of new computing and artificial intelligence research and in bringing those together. So it's a combination of the intellectual fabric across the institute and the forefront of new computing education and research. The college consists of a number of existing MIT academic and research units, in addition to new programs, and I'll touch on both of those. In terms of the existing units, on the academic side, there's the Electrical Engineering and Computer Science Department, EECS, or Core 6, which is the largest department at MIT. And that has now been structured into 3, what we call faculties that focus on 3 areas: electrical engineering and computer science, and then a new area called AI&D, which stands for artificial intelligence and decision-making. And that brings together the computer science heritage, artificial intelligence arena, with that of decision-making, decision theory, information theory that had tended to more be done in electrical engineering. And with the advent of machine learning, these are really coming closer together. And so we're building a new area in the department focused on that. In addition to EECS, there's the Operations Research Center, the Institute for Data Systems and Society, which has the Statistics and Data Science Center and the Technology Policy Program within it, and the Center for Computational Science and Engineering. EECS is part of both the New College of Computing and part of the School of Engineering. And the Operations Research Center is part of the New College of Computing and Sloan and the Sloan School. And so what you already see in looking at these units is that the college, in addition to having significant academic depth, collaborates with the schools, in this case, Sloan and the School of Engineering, in delivering those programs. On the research front, the Computer Science and Artificial Intelligence Lab, or CSAIL, which is the largest research laboratory at MIT, the Laboratory for Information and Decision Systems, or LIDS, the Quest for Intelligence, which studies human and artificial intelligence, the MIT Watson AI Lab, which is a collaboration between MIT and IBM, and the Jameel Clinic for AI and Health are again all part of the college. And the MIT IBM Watson AI Lab is also again jointly with the School of Engineering. So that's the collection of units at MIT, and it comprises a large part of the faculty and of the students and of the researchers at the institute. One of the things that's critical about bringing all of these program areas together is that computing programs and computing research and innovation are evolving very rapidly. And so there aren't really clear boundaries like there often are between more established disciplines. And the boundaries are actually changing pretty rapidly. So when we look at computational science and engineering, or CSE, which is numerical methods that are applied in different disciplines: electrical engineering, computer science, operations research, artificial intelligence and decision-making, technology policy, statistics and data science, and the social engineering systems graduate program in IDSS, these all overlap in different ways with one another, and the boundaries are shifting. For example, a decade ago, you would not have called operations research in all likelihood a computing discipline. But today, operations research is fundamentally a computing discipline. In addition to these existing program areas, there are some new cross-cutting areas that are being developed by the college. And the two that we're furthest along with are what's known as the Common Ground for Computing Education, and what we refer to as SERC, or Social and Ethical Responsibilities of Computing. The Common Ground is aimed at multi-departmental collaborations in computing education to meet the needs beyond any single class, to create blended and integrated computing classes and curricula. And a critical aspect of the Common Ground is helping educate what we call computing bilinguals, those who are experts in some aspect of computing and in some other discipline. And not just in using computing as a tool, but in computing as part of the intellectual framing, intellectual fabric of that other discipline. SERC is focused on building habits of mind and action, really ingrained things that people do almost automatically, and considering the impacts of computing as they develop new algorithms and new computing systems, and incorporating multiple perspectives from the humanities and the social sciences and engineering and computing, including a focus on the responsible deployment of computing technologies. And I'll talk a little bit more about each of these in a moment. Diversity, equity, and inclusion is also a critical aspect of the college. And we're focused on creating and supporting a culture of belonging where people of different backgrounds feel welcome and encouraged. And this is part of broader DEI efforts at MIT. One of the things that we think is really important in the way we're approaching this in the college is that the ways in which people approach diversity, equity, and inclusion differ. And so we, in part, are seeking to engage in respectful and what are sometimes challenging discussions for each of us to broaden our understanding and the inclusivity of our programs. A particular focus for us is improving the diversity of graduate programs. And this really warrants highly innovative solutions because our graduate programs actually have lower diversity than our undergraduate programs at MIT. And so this is something that we're paying special attention to. This last year, we hired Alana Anderson, who's a newly hired assistant for diversity, equity, and inclusion, and she's helping us frame and support the faculty and the students and the researchers in these objectives. So now I just want to go through a few topics. First and foremost is faculty hiring. This, in an area like computer science, artificial intelligence, which is growing and expanding so quickly, is critical. One of the things that the college has enabled is what we call shared faculty hiring. These are faculty who are appointed in a department somewhere at MIT and also in the College of Computing. These are sort of the research and teaching bilinguals. And we have 25 or more such shared faculty positions. We're doing 5 searches currently this year. And we did an MIT-wide strategic planning process in order to focus on the areas for these shared faculty hires. And 5 key areas we came up with are the social, economic, and ethical implications of computing and of networks, computing and natural intelligence, which includes cognition, perception, and language, computing in the health and life sciences, computing for health of the planet, and computing in human experience. And this year, we're doing a search with philosophy in the social and ethical implications. We did an initial hire with Sloan School in that area last year. We're doing a search with architecture in computing and natural intelligence, having done some hiring with brain and cognitive science previously. And because of the incredible importance of climate and climate change, we're doing 3 searches this year with EAPS, mechanical engineering, and nuclear science and engineering in computing and health of the planet. In addition to these shared hires, it's important to continue to build and broaden the core base of computing faculty at MIT. And we've done 17 core faculty hires in electrical engineering and computer science since the college was founded. And the purpose of this slide is not to go through them and their amazing backgrounds, but rather just to show the number and the breadth of the people that we're hiring. And they're across computer science, the new artificial intelligence and decision-making faculty, and electrical engineering. The second area I wanted to touch on is education, and this topic that I brought up before of educating computing bilinguals. And really one of the core educational objectives of the college is to coordinate computing education across disciplines. There are two major ways in which we're doing this. One is blended degrees at the undergraduate level, which goes beyond simply combining two majors, like you might with a double major or a major and a minor, and really creating something that arises out of active engagement between faculty in two programs to put together a new major that spans two areas. And right now, we have a number of these, and we're not adding new ones until we better understand the ones that we have. The second arena that we're looking at and executing on in developing computing bilinguals is what we call the Common Ground for Computing Education, which I mentioned before. And this is aimed at developing individual subjects and perhaps, in addition, sort of pathways through sets of subjects that bring the forefront of computing together with the problems and the methods in various disciplines. And this is also tied to SERC, the social and ethical responsibilities and education on that. So with respect to blended CS majors, so these are people getting degrees, we have 3 new blended majors that we've launched in the last 3 or 4 years, which build on a major from a decade ago, CS in molecular biology. And you can see the very large number of CS majors, about 42.5% of MIT undergraduates, or about 1,450 students are majoring in some variant of electrical engineering and computer science, or Core 6. But what you can see here is that the blended majors now, indicated by the bracket here, are about a quarter of all of these majors, really having only, for the most part, been developed in the last few years. CS economics and data science, computation and cognition, and urban science and planning with CS are the 3 new blended majors. And they've been getting tremendous reception from the students. In fact, each of these majors is of comparable size, if not larger than, the corresponding major in the department that we're partnering with in developing and delivering them. The Common Ground, as I mentioned, is multi-departmental collaborations on teaching and education. So this is developing classes and curricula that not only meet the needs of different departments, but also offer the perspectives of those different departments and programs. They're developed and offered jointly by 2 or more departments focused on computing education. And there are 3 focal areas, plus the coordination with SERC that's incorporated into everything we do in the Common Ground. And those 3 areas are the fundamentals of programming and computational thinking. So that's introductory material, but it can be at graduate as well as undergraduate levels. Machine learning, artificial intelligence, data science, and algorithms. And again, in the context of the disciplines, because the Common Ground for Computing Education is bringing together computing with various disciplines. And then fundamentals of computational science and engineering, another area that is at its core about bringing computing into science and engineering disciplines. So we piloted another number of Common Ground subjects in the last year and a half. One is a new introduction to computational science and engineering, joint between aero, astro, and mathematics. One is a linear algebra and optimization class, joint between ECS and mathematics. One's a modeling with machine learning class. And this one's quite interesting in that well, they're all very interesting subjects, but this one's organizationally quite interesting in that we found that in the very large machine learning class that was being taught in computer science, many of those students, in fact, most of those students we're more interested in using machine learning as a modeling tool in some other discipline, rather than learning the fundamentals of machine learning as it gets taught in a CS class. And so we developed this new modeling with machine learning class as part of the Common Ground, together with half a dozen departments, so that students take a core machine learning module and a module in the department that's most relevant to them. And they're very closely coordinated co-requisite classes. We're also looking at computing in the very introductory curriculum and looking at how do we potentially embed computing in the introductory physics classes at MIT, and doing some pilots on that. We're also looking at education and computing more broadly with online executive and professional education. How do we bring these recent and important computing advances to professionals? We're focusing on the quality and the relevance and coordinated curricula, and also on increasing the visibility of what we're doing at MIT in leading in educational development. One of the core examples of that is a new program between the Sloan School and the Schwarzman College of Computing, focused on business and computing. And this is an area where we think there are really big unmet needs for leaders in business and in government, both in technical and in non-technical roles. And the first class that we're offering under that is called Making AI Work, Machine Intelligence for Business and Society, and that's just launching. Just went through its pilot phase and it's just launching. Also, we're planning new master's level programs through the MITx MicroMasters, again, for working professionals. So on the societal implications of computing, SERC, Social and Ethical Responsibilities, looks at teaching and research and engagement beyond academia. And in the COVID era, we've been mainly focused on teaching and research, and a little bit less on engagement just due to the restrictions of how we're working outside of the MIT community at the moment. And I'll touch a little bit on an example of both. So on the research front, the SERC is developing an ethical computing platform based on a protocol that was created by collaboration between people in computer science, people in robotics, people in philosophy, people in other humanities disciplines, really to allow people to identify and address and communicate about the ethical and social aspects of the technologies that are being developed in a structured manner, to make it easier to develop language for people to talk about these kinds of concerns across disciplines. So things about looking at research design, data collection and protection, unintended consequences, and aspects of systems. And this protocol is now actually being implemented in an online platform in collaboration with a project in the MIT Quest for Intelligence. On the educational front in SERC, an example of what we've done are the case studies in social and ethical responsibilities of computing. And this set of case studies are publicly available at mit-serc.pubpub.org. Every 6 months, we have a set of 4 to 6 new cases authored by faculty from around the country and around the world, reviewed by a panel of MIT faculty and by groups of MIT undergraduates, because these cases are intended to be aimed at the undergraduate level, which bring together everyday problems around data and mapping and facial recognition and criminal justice, where computing technologies are being used, and in a case study sort of style of inquiry, look into those and produce materials that can be used at MIT and elsewhere in education. Another thing that we've been focused on are the policy aspects of AI, again, in the social and ethical responsibilities of computing more broadly. And so we've been convening a series of individual and group discussions where we bring together people from different backgrounds, from policymaking in government, from companies, from academia, to have more deeply informed discussions about AI policy issues with one another and with MIT faculty experts. There are 3 areas we've been focusing on: finance, healthcare, and mobility. And some of the examples of what we've been doing are some collaborations with the OECD, something we call Global Deep Dive that brings in people from countries around the world at different levels of economic development, and things we've been doing here in our own nation's capital in the United States, in Washington, D.C. But with the advent of AI, regulation is very much on the table, and we need to make sure that that regulation is well informed, both in terms of the social aspects of what it's attempting to do and the technological aspects and capabilities. So next, I wanted to turn to the research arena, talk a little bit about synergies in research, and then a few highlights in research. With the mass of research at MIT, with literally almost 200 principal investigators in CSAIL and LIDS and the laboratories in the college and computing research across the institute, there's no way to summarize all of the research, but I picked a few research synergies areas and then a few example pieces of research. So one critical synergy area for us is computing in the life sciences. This is health, the biological sciences, and there are three areas where we have collaborations ongoing between MIT and other entities. So one focus of that is the Jameel Clinic, which looks at AI in health, and really at taking AI and machine learning and translating that into practice in collaborating with healthcare providers. So we've had a set of conferences on AI in healthcare and on drug discovery, but also a set of collaborations with big healthcare systems in evaluating new machine learning and artificial intelligence techniques in the clinical setting. There's the new Eric and Wendy Schmidt Center at the Broad Institute of Harvard and MIT, which is focused on data science and biology. Caroline Euler, who's a EECS faculty member, is the MIT co-director along with the Broad Institute co-director. And we're looking to do additional faculty hiring this year between the Broad and the college in the EECS department. And then, as we've all seen, the incredible importance of immunology in the pandemic, there are seed projects now funded by a donor to build connections between the Reagan Institute, which focuses on immunology research, and AI researchers at MIT. And that's being led by the Reagan Institute director, Dr. Bruce Walker. Another important synergy area is AI and natural intelligence. I mentioned the undergraduate major, that what we call 6-9, which is computing and natural intelligence. The quest for intelligence is a research activity that corresponds to that. And in the quest, we look at the engineering and systems problems of artificial intelligence and the scientific challenges of how we understand human intelligence and other forms of natural intelligence is really aspects of the same collaborative grand challenge. So they're not, in the quest, we don't approach AI and human intelligence as separate, but really look at the interactions between them. And we've been putting together over the last year a broader set of missions where each mission both asks foundational questions about natural intelligence and does so in an arena where current artificial intelligence falls short, doesn't deliver. And the objective of this is to advance both the science and the AI. And so there are four areas, one around how intelligence develops, either in people or in machine learning systems, one on embodied intelligence, intelligence in entities rather than sort of floating in space as most machine learning is, new hardware architectures for intelligence that are motivated by neural systems, and collective intelligence and behavioral intelligence. In terms of some illustrative research areas in the college, an interesting one is energy efficient AI, and this cuts across a number of the research labs and activities in the Institute. So how you build faster and cheaper AI with neuromorphic chips, how you reduce redundancy from insights of primate visual brains, how you create next generation hardware that's much more efficient, how you shrink AI to run in low power environments like Internet of Things. Very exciting and important area around AI at the edge and energy efficient AI. In terms of the two main research labs in the college. LIDS, Laboratory for Information and Decision Systems, focuses on statistical inference in machine learning, optimization and game theory, and systems theory, control and autonomous systems, and networks, all the way from communications to social networks. And it typically does cross-cutting research in those core areas involving faculty from different departments at MIT. CSAIL, which as I mentioned before, is the largest research lab at MIT, does work across a wide variety of areas. It's got over 100 principal investigators working in the lab, and they've organized into communities of research, which I think helps understand a little bit better the broad swaths of work that are going on at the laboratory within the institute. So there's a human-computer interaction community working on computing systems, one looking at theoretical aspects of computing, algorithms and complexity, one on vertical AI, which takes an approach to the whole range of research areas from hardware all the way on up to applications, visual computing, an applied machine learning research community, cognitive AI, so you can see AI and machine learning cover a lot of what's going on. One on computing and society, so looking at the social impacts of computing and the impact on not only on society, but the impact of societal issues on computing and the development of computing and AI. And then one on embodied intelligence. So just a couple of quick specific examples. Recent one by Regina Barzilay, Tommy Yakala, and Octavian Ganea in CSAIL is on drug discovery, where the search for new drug-like molecules can often involve a lot of guesswork. And so they, along with a number of researchers at other places, have been developing new methods that make it much easier to understand the 3D properties and the 3D shape of proteins in designing new drugs to really help speed up drug discovery. In the MIT IBM Watson AI lab, there are a number of interesting projects going on. Just picked a couple that I thought were of particular interest. So one is Dean Eccles at Sloan with a collaborator at IBM. Increasingly, we have privacy-preserving ways of aggregating data, but that still doesn't mean that these data won't have unintended effects, even when they're used in an aggregated manner. And so in this research project, they're looking at those kinds of effects. Another project that's going on in that lab is called Bringing 2D to Life, MIT faculty member Wojciech Matuszek, and a collaborator at IBM. And it's about how you could take 2D imagery and 2D video and create a really photorealistic and interactive 3D environment. So in closing, I just wanted to touch for a moment on the new building being built for the College of Computing, which will open in the summer of 2023. It's designed to be a building that, like the college, the college spans MIT. It's intended to draw people in. This building is also intended to draw people in. It sits right across Vassar Street from the EECS department and CSAIL and LIDS in the Stata Center. So right there in the heart of much of the computing research on campus. So with that, thank you very much for joining me in this presentation today. And I look forward to speaking with you all.